This is a continuation of our Regents Review from Green Book number 5. It has to do with a vectors question. We know it's a vectors question because the key phrase here is force. So we know we've got our parallelogram of forces that we're going to draw. Why don't you read through the question, make a sketch that shows the two forces and the resultant, and then play the recording when you've got that sketched. Okay, so hopefully you've got something like this. You've got a parallelogram, 1,500 pound force, 2,000 pound force, and the resultant drawn in on the diagonal, which is a 3,000 pound force. Next, the angle here in blue is the one we're trying to find, the angle between the two applied forces. However, if we consider one of the triangles, this red top triangle would be fine, or you could use the bottom triangle. The blue angle is not an angle in either of the triangles, so we can do it two ways. We can find out this part and add them up, but that's twice the calculations, or we could just find this theta and then subtract from 180, because consecutive angles in a parallelogram are supplementary. I think I'm going to approach it that way because it's less calculations. I have to think about what I want to do to solve this triangle with a side, and I want to know an angle. I'm going to use the law of cosines here. There's our setup for law of cosines. The 3,000 is all by itself because it's across from the angle. I made a little mark here. And then you just sub in the other two sides. They're interchangeable. Now I have to do some math. Because the theta is way over here, I can't just put it all in the calculator. I have to square and square and square and multiply this out. So there it is. Now I need to take these like terms, these just numbers here, subtract them from the 9 million. And now I need to divide by negative 6 million. And then do the inverse cosine, and I get 117.28 degrees. That's the red angle, but that's not the angle between the two forces. So I then need to do the supplementary angle, which when I subtract from 180 gives me the angle of 63 degrees. Next question is a question that involves a triangle. Okay, so we've got a triangular piece of land, and it wants us to find the price. So we've got several steps we have to do here. Let's make a picture to start off. So we know we've got a triangle. We know the three sides are given at 50, 75, and 100 yards. The first step is we're going to need to find the area and then multiply that area by the price per square yard. However, the area formula for an oblique triangle requires two sides and the angle in between. So the first thing we're going to have to do is find one of the three angles. You can find any of the three angles. I'm choosing to find this one. I've marked theta. So because I have three sides, I want to find an angle. That tells me law of cosines. I'm going to set up a law of cosines so that the 100 is across from the theta. Okay. Next, I work that out, just like before. Do my inverse cosine because I'm solving for an angle. I get the angle is about 104.4775 degrees. I'm keeping lots of precision here because I don't want to round too early in the process. Okay, I don't want to round and use a rounded answer. I will lose precision. Next, I need to find the area. Now I have an easy question to do. It's side angle side. To find the area, we use 1/2 AB sine C, where C is the angle in between sides A and B. Sub in the stuff we know. And there's our area. Again, I'm keeping lots of precision here, and the unit is yards squared. Now I hop up here. The question said, what is the price? Okay. So I just multiply the price by the yards squared, and I get to the nearest $100 that it's $2,700. Our next question is the law of sines question. We have a double triangle question. Sometimes they don't give you the picture. This one does. So we want to know the height of the tower to the nearest foot, and we're given some angles of elevation, one right triangle, and we're given that the distance between those two measures is 100 feet. I'm going to annotate that picture a little bit, and I'm going to put in all the angles that I know. Concentrating on the purple triangle, I've labeled all the angles I know using the fact that we have supplementary angles here, interior angles of a triangle here, and then interior angles of a triangle here. I want to find angle x, however I don't know any sides in angle x. I only know angles. So it's of no use to try our SOHCAHTOA here. We can't use Pythagorean theorem either, so we don't know any sides at all. So I'm going to do an intermediate step and solve for a triangle, solve for a side of a triangle that is shared by the purple triangle and the right triangle over here. So I'm going to solve for angle y. You can do that with your law of sines. You've got a side and an angle that I'm involving here, and a side and an angle that are known. So let's set up a law of sines. Sine of 32 degrees across from y, sine of 33 degrees, which is the angle across from 100, multiply through by the LCD, and work it out. Y is about 97 feet, and that makes sense because 32 is just smaller than 33 degrees, and the side across from the 33 degrees was 100 feet. Always want to check for the reasonableness of our answers. But that's not the answer to the question. The answer to the question was, what is the height of the tower? So now I'm focused on the blue triangle. In the blue triangle, I now know a side. We said this 97.2973 feet. Now I can use law of sines, or I can just use SOHCAHTOA, because I have a right triangle. So sine of 65 is equal to the opposite over the hypotenuse. Multiply those two sides, and you've got x is 88 feet. Again, if I want to check for the reasonableness of that question, across from the 90 in the blue triangle is a 97-foot side length, and across from the 65 is a slightly smaller side length. It's 88 feet. Seems reasonable. Our next question, to finish this out, we have a couple questions involving graphing details, period, amplitude. So this question says how many seconds are in the period of the oscillation. Okay, so there's a lot of language in here. They have a nice context about an object suspended in liquid, but really the key is, here's the equation. We're looking for the period, and we know that period is defined as 2 pi over b. The b value is always the coefficient of the variable x, or in this case, t. So we just put 2 pi over 8. We simplify to pi over 4. Our last question involves the amplitude. Remember, the amplitude is the a value if you're given the equation of the function. If you're given the graph, it's the amount that the graph rises above the nodal line. So this is a pretty straightforward question. There's not a lot of work to do. The amplitude is simply the absolute value of the a. The amplitude is half. You can check that if you want to make a graph. Thanks for watching.